Okay, the last question is from slide 26, and I've edited a little bit, but it says, what is the frequency? So we're looking for F for the first part of this question. If the wavelength of a wave is 10 meters, so that's lambda is 10 meters, and the speed is 420 meters per second, so V is 420 meters per second. So here, for the first part of this question, we're going to be using speed equals lambda, the wavelength, times the frequency. If we're solving for the frequency, for those of you guys using the triangle at home, then it'd be wavelength times frequency over speed. So if we were to cover up the frequency, it'd be speed over lambda. So speed divided by the wavelength will give us our frequency. And so we're going to plug in 420 meters per second and divide that by the 10 meters. And what we end up getting here for the frequency is then 42. Now the units, meters cancels with meters, and we're left with just this per second. And whenever we have per second, then we are going to call it hertz, Hz. And so that's the answer to the first part of this question. The second part of the question is something I edited, but it wants to know the period. And so we're going to use all that same information, all the same information that's given in the problem. So we still have speed of 420 meters per second. We still have a wavelength of 10 meters. But if it wanted to know the period, we have one of two ways that we could go about doing this. The easiest is using this given information. And so remember, in the first part of the problem, we calculated this frequency to be 42 hertz, okay? And so we can first use wavelength divided by the period is equal to the speed and solve for the period, because then rearranging that equation, the period would be equal to the wavelength divided by the speed. This would be a way that we wouldn't be able to screw it up, because this is all given information, and this would be recommended way of solving it. So we put 10 meters all divided by 420 meters per second, and this would give us the period of, let's see, 10 divided by 420 of 0.238, kind of an ongoing decimal number here. Seconds, because meters cancels meters, and the per seconds is on the bottom, so it becomes just seconds. However, you could use the fact that the frequency is the inverse of the period, and so period would be 1 divided by the frequency, and so we could also solve this 1 divided by the 42 hertz, and we should get then the same answer, which does come out to be 0.238 seconds. So really, we can solve the second portion of this problem in one of two ways. Both give us the same answer. So good luck on the assignment today. And if you have any questions, just shoot me an email.